time variant and invariant elements. So today we are going to discuss this one major thing, guys. So last class we discussed active passive, right? So we are dealt with so many graphs and you guys were able to understand the topic, I think. So today we are going to talk the next pairs of classification, that is time variant and invariant systems or elements. The elements, the element whose property changes with the time are said to be the variant. The property changes with time. So properties changes with respect to time, change with the time will be said to be time variant element. So property remains same over the time. So property remains same. So here the properties mean nothing but the resistance or inductance, impedance, any kind of things that is contributed by the element. So the property will remain same here. Okay, so that is what the quiet difference between the time variant and invariant. Similar to signals and systems, how we are classifying the system, right? So TVI, time invariant system, right? So similar to TIV. So similar to that, we are stating here. So practically over a long time, property changes. So elements are time variant. But in network, we consider only small duration, right? So in a network, we are considering only small amount of duration we are going to consider. So in which we assume all the elements are said to be time invariant. Okay, so that is what the practical thing that we are going to state. So here, nothing more to discuss here. So next set of classification is lumped and distributive element. So I think in RF, you guys will be able to see this distributive and lumped systems. So let me explain this here clearly. So lumped and distributive elements. So thing is that if entire property of the element is assumed to be concentrated at a single point, then this is said to be a lumped element. So the thing is that the entire property is at single point. So entire property of the element. So entire property of the element is concentrated at single point. So this one we be calling that as a lumped. Example is the normal. Everything we take that normal capacitor, inductor, everything is this example. So thing is that the ceramic resistor, and ceramic capacitors. Even electrolytic capacitors will come under the example of this one. So ceramic capacitor. So okay, so these are some example of the lumped element. Means if you see entire property of the element which will lie at the particular thing only, the resistor that only. So that is what the thing. So the opposite to that of the distributed element is that, so if the property is distributed at each point, so the property will be distributed to each point. I will explain it. So property is distributed at each point. Within the element. It's a very important thing, within the element. So this thing we stated as a distributed element. So example, the best example is the transmission line. So transmission line is nothing but in RF we be using some lines to transmit the high frequency signals. On the time what will happen is that the property will be repeated. So some kind of properties will be repeated at every point. So that's why we state this is a distributed element. So Kirchhoff law cannot be applied to the lumped element. So Kirchhoff law KVL, KCL only be applied to distributed, lumped elements, not for the distributed. So this is one important thing. In RF, these kind of rules may not be applied. So there we use different calculation. So if time permits, so once all the basic core subjects are completed, I will take RF also. So don't worry about that thing. So for now, please make a note of it. So only at the lumped element, the different KVL, KCL, those things will be coming into picture. Okay. So from here, we have completed some majority of things. So next we start with the linear and non-linear systems elements. Okay, so the fourth bar is linear and non-linear. So linear as well as non-linear. Okay, So linearity will generally be stated with the two principles: superposition and homogeneity. Homogeneity, superposition plus homogeneity. So if the equation or if an element follows these both the thing, then we call that as a linear. So purpose of the system is to process the input and generate the output, right? So if we take the general system is nothing but an interconnection of components. So don't worry about that thing. So it's just a components. Maybe this is, if we consider this as a system, but there may be any capacitive or any inductor, any kind of a circuit will be there. So that is what generally stated as a system. So here we provide input and we get some output. So this is y of t and this will be x of t. The system need to process the input and need to produce the output. So that is what the thing. So the superposition. So here what the superposition will do is that, so if x1 of t is given, it need to produce the output y1 of t. If the different input x2 of t is given, it need to produce the output y2 of t. Okay. So even if these two are added and combinedly given x1 of t plus or minus x2 of t, the output need to be y1 of t plus or minus y2 of t. Okay, so that is what the thing. So if it is follows this principle, then we call this as a superposition theorem. So second thing is that homogeneity. Homogeneity is nothing but if we give the input x of t, the output will be y of t. So that is fixed. So whenever we multiply a constant, then output also need to be multiplied by the same constant, a times y of t. So if this is follow, if the input is scaled by certain factor, then output also need to be scaled by the same factor. So the linearity will come into picture whenever these two principles are matched or these two followed. So superposition plus homogeneity. Okay, so this is the rule to find whether the element or whether the signal which is a linear or non-linear. The rule may be quite complicated, but it will be very easy for us to find out. So that will not be a problem. So if we have to combine both the thing, then a times x1 of t plus b times x2 of t, the output need to be a times y1 of t plus b times y2 of t. So if this is follows this one, then that element or that particular thing is linear. So when a linear combination of two input is applied to a linear system, we get the linear combination of the corresponding output with the same constant. So that is what the thing. So for the linear system, the Vi characteristic must be straight line passing through origin. So we know that, so the slope need to be y is equal to mx. So that's what, plus c should not come. So if this is follows, then we can clearly state that element will be linear. Okay. So let us now go through some examples here. I think this will be fine. So let me erase few things. Let me take the same graph that we have used so far, right? So let me copy paste this one. Okay, so now I am going to take few examples. So if plus minus v, so this is there and I is in same direction, and if the graph is passing through the origin, if the graph is passing through the origin, then what will be this element? So we know the slope is the power is positive here and power is also positive here. So means here this is passive element, this we already dealt with. So this is positive element, and if we see the line is passing through the origin and it is following the slope, the Vi characteristic follows the y is equal to mx relationship. So means this is a linear. So here we are going to add another one thing. So whether the element is linear or non-linear. Okay. So that is what the thing. So next, let me take this one. So here same positive, negative, the voltage is applied and input I is given here. And if we supply the thing, if the Vi characteristic curve is passing like this, then what the thing? So here if you see the slope is less than 0, means the element is active. So that we can clearly say the element is active. And it is not passing through, the y is equal to mx is not here. Okay, so plus c, so constant is getting added here. So means this is non-linear. Okay, so this is how we need to find out whether the element is active or non-linear, everything that we have to find out. Okay, so I'm giving this as homework to you guys, so please try this one, how you can do it. So please pause the video and try to answer it. So here we are considering the thing that, so we are supplying the same positive negative voltage and current is entering the I terminal, and the VA characteristic curve, how is it? It is like this way. It is like this. So then what will be the element? So whether it is linear, non-linear, whether it is active or passive. So please pause the video and try to answer it so that you guys can able to get it. So let me solve this answer. Here if you see, if we consider only up to this transition, this will be linear. But after this is not following y is equal to mx. So means even if it is at some point of time it breaks the rule, then the entire element will be considered as non-linear. And here the slope is always positive, so means this is a passive element. Okay, so this is in first quadrant and third quadrant only, right? So this will be always positive. So let me give you another one example. I think this will be this we already dealt with. Okay, so let me give one simple thing so that you guys can able to solve it easily. So plus minus V, the current is entering like this, and we are having the parabola. So parabola effectively we are having. So what will be the element that will be there? So please pause the video and try to answer it. So we can clearly state this is non-linear element. So this is non-linear, and here power will be greater than 0, and but here will power will be less than 0. Means this will be active element. Okay. So this is very important, guys. So plenty of time these questions are asked in IES exam. So please make note of it. How with the help of VI characteristic curve we can able to find out whether the elements, what are the type of element and what is the property behind it. So this will be a very good thing if you guys were able to understand the things. Okay. So far we have find out 4 properties of things. So here is the last thing that we are going to discuss, that is bilateral or unilateral. So this will be the last thing. So bilateral and unilateral elements. Okay, so bilateral, here the property of the element should not change in when the direction of current is reversed. So the property should remain same for all the direction of current. So the property of an element shouldn't change should not change when direction of current is reversed. Okay, so you guys can state a best example here. Okay, so when the current is passed in one direction and the current is reversed, the element should not, the property of the element should not change. So examples are RLC. So these are the circuit where the element's property will not change depending upon the current. So unilateral element is the thing that what will happen is that the thing will change. The elements, those property will change. So best example is that the diode. So in diode, if we consider, so when we give the forward bias condition, the current will conduct. So R which will be equal to 0. But when if the current is flowing like this way, so this is diode, right? So if the current is reversed, then the diode will be break. So diode will not conduct. So if the current is going like this, then the property will be infinity. So here if you see based upon the current direction, this will be changing. So diode are said to be the unilateral element. So if the VA characteristic curve are symmetric about the origin, so if the VA characteristic curve is symmetric about origin, then this will be the bilateral element. So VI characteristic curve is symmetry about origin. Symmetrical about origin. Then that will be called as the bilateral element. Okay, so if it is not symmetrical about the origin, then we call those element as a unilateral element. Okay, so that is what the thing is. So now we are going to discuss few more examples like how we can find out the all the three in a single set. So let me take the thing, so how we can do it. So this is the property of element that we are going to think. So here we are going to solve few problems so that you guys can able to clearly understand the things. Okay, So this will be direction, and this will be the IV characteristic curve. So here the curve is passing like this way. Let me, before that, let me copy this one. So this is IV. So this is I and this is V. Okay. So let me take the assumption that it is positive. This is V and the current is entering the positive terminal. And how the graph is looking like this way. The graph is looking like this. So this property we have already solved, right? So here you let me solve this one. From next you can solve. We know that there is a non-linear element. So this is non-linear and this is a passive element. So this we already dealt, because here the slope is always greater than 0, power is always greater than 0, and this is not following y is equal to mx. So here if you see, the characteristic curve is symmetrical. So this will be, if we hold this about the origin, the graph will be looking symmetrical. So about the origin, if you hold the first quadrant and the third quadrant, the graph is exactly similar. So if it is symmetrical to origin, then we can state this is a bilateral element. So just now we have dealt with this, right? Though if the graph is same over the quadrant about the origin, so this will be called as a bilateral element. So here we are stating this is a non-linear passive bilateral. Okay, so I'm giving you next example. So here you guys can solve this one and find out the things. So here the same, before that let me copy this one. Okay, so this is same, positive, negative. V, current is entering the I. Okay, so here the same, graph, but the thing is that here they are given some values. This is 4, so this is 4 and this is minus 5. So this is 4 and this is minus 5. So now you state whether the element is linear or non-linear, whether it's bilateral, unilateral, or passive or active. Please pause the video and try to answer it. So let me do answer it. So here every time the power is greater than 0, so this element will be passive, there is no doubt in it, and this is non-linear, as we know, that is not following y is equal to mx. For the bilateral or unilateral, the first quadrant graph and third quadrant graph need to be same. But here if you see, the values are quite changing. So here it is 4, but here it is minus 5. So means this is not in the bilateral condition. So this is in unilateral. So this is how we have to solve the different problems. So let me give you one more thing so that you guys can able to understand it more clearly. So let us take this is a last example. So here positive, negative, which is given, and I is entering like this way. And let's take a parabola. So sorry for my parabola, let me redraw it. Okay, so if it is like this, so then what will be the property? So please pause the video and try to answer it. So here if you see, the power is less than 0, here the power is greater than 0, means this will be an active element. So this is definitely not a linear element, so this is a non-linear. And the first quadrant, third quadrant, this is not symmetrical about origin, so this will be called as a unilateral. This is how, with a simple VI characteristic curve, we can find the different properties of the things, guys. I hope this will be very helpful for you guys. So don't skip these lectures, this will be very important. So please understand all the concept. If you guys have any doubt, please post in the comment section so that I will be there to solve your doubts. Okay, so please like, share and subscribe channel. Stay tuned, guys.